Hello everyone, I'm Mahdi Ashur from Tunisia, from the University of Sousse. I will present today my paper entitled Multi-Objective Optimization for Sensor Networks-Based Smart Parking System. For the plan of the presentation, we will introduce first the sensor networks and the energy problem and the smart parking systems based on sensor networks. Second, we have the description of the smart parking system, the architecture and different layers. Thirdly, we have the more mathematical formulation with the multi-objective optimization and the linear programming model. Fourth, we have the performance evaluation with the numerical experiments with the linear programming solver LPSolve and the simulations with the Visual Sense simulator. And we finish by the conclusion. So the sensor network consists of many connected sensor nodes which detect environmental measures like temperature and humidity and relay them to the base station, which also called the sink. An energy problem occurs often in the sensor networks. It consists that the nodes close to the base station relay a large part of the traffic, so they risk to quickly deplete their batteries. This is known as the crowded sample effect. As a result, the base station is isolated and the peripheral sensors are unable to reach the same. So a solution based on the mobilization of the base station consists that a mobile base station move around the coverage area and stop in many stop positions to collect data. We pass to the smart parking system description. Here we have a smart parking system containing many lots, and we have a sensor detecting the state of the different lots and send the information to the cloud. And when new drivers enter to the park, they can use mobile applications to connect to the cloud and receive the information about the states of the different lots. Here we have an example of a smart parking mobile application. This is the architecture of the smart parking system. We have many ultrasonic sensors connected to an Arduino card. We have also another Arduino card connected to the monitor, and all the Arduino cards are related by an XP Pro module. You can see here the ultrasonic sensor, which receives the ultrasonic pulses that relay back information about an object's proximity, and the XP Pro module use it to connect the Arduino microcontroller in the parking lot with the Arduino monitor. So our system is composed of 4 layers. We have the sensing, the networking, the middleware, and the application layers. We will see them in detail. We have first the sensing layer describes the deployment of sensors in the car park to detect the presence or absence of cars with radio frequency identification chips. The networking layer is used, in this layer is used the ZigBee standard for the routing of data from sensor to the base station and TCP over IP over Ethernet to connect the base station with the server. For the middleware layer, it includes databases and servers capable of providing intelligent services and linking the application layer where services are requested to the lower layers. The application layer includes mobile application for smartphones, tablets, and laptops. These devices are connected to the parking database to know the state of the parking. We pass to the mathematical formulation. So we propose a multi-objective optimization aiming to maximize the network lifetime and minimize the distance between sensor nodes. The travel time of the base station becomes shorter. Another contribution consists that the traveling time of the base station is bounded by the average time of two successive arrivals of drivers. So the multi-objective optimization problem is formulated as a linear programming model. We have here the objective function. It aims to maximize the network lifetime while minimizing the distances between sensors. And the network lifetime is defined as the sum of the residence times of the sink in all the stop positions. We have also many constraints in the linear programming model. So we have the first constraint is the flow conservation constraint. Means that the sum of the outgoing data flows is equal to the sum of incoming data flows plus the data generated by the sensor. The second is the energy constraint. It means that for each sensor, the energy consumed in transmission plus the energy consumed in reception is less than the initial energy of the sensor. Third constraint ensures that the traveling time of the base station is less than the average time, the average arrival time of two successive drivers. And fourth, we have the non-negativity constraints. So we solved the linear program with LPSOL, and here we have the different values of the decision variables. We also performed many empirical experiments. So we can see here the results. We have the network lifetime depending on the number of base station stop positions and the number of sensors. So it's clear that the lifetime increases with the increase of the number of base station stop positions. So which prove the efficiency of the mobility for the base station. We have another experience we have here. We have the arrival time, the base station stop duration according to the arrival time interval. So the stop duration is here for two stop positions, and we have the arrival time interval. This curve shows a comparison between using mobile and fixed base stations for sensor network, 20 sensors and two stop positions. So this curve shows that the mobile base station increases more the network lifetime. We also performed simulations with Visual Sense Simulator. Here we have an example of a car model entering the parking. You can see here the empty lots are in green and the busy lots are in red. Conclusion, so we proposed a model of smart parking management that consists of 4 layers. The improvement touch, especially the network layer, using a mobile base station. We have also formulated a linear program for multi-objective optimization, which aims to maximize the lifetime of the network while minimizing the total distance between the sensors to reduce the travel time of the base station. Thank you for your attention. I finally like to thank the organization committee for this conference, and I hope to meet you next year in ISDA 2020. Thank you again, and goodbye everyone.